Today what we're going to do is we're going to move on to section 7.6. We're going to apply the sine and cosine ratios. If you remember from yesterday, we worked with tangent. And when we worked with tangent, if you remember back, tangent was the opposite over the adjacent. And when we looked at the triangle, and I drew a right triangle, again, it works just on a right triangle. If I'm looking at this angle right here, this side was considered the hypotenuse. The side next to it on the bottom was considered adjacent. And the side across from it was considered the opposite. So really what we were doing is we were looking at only two sides with tangent. We looked at the adjacent, which was here, and we looked at the opposite, which was here. Those were the only two sides. Today what we're going to do is we're going to look at sine and cosine. We're going to set up our sides very similar, but rather than doing the opposite over the adjacent, we're going to do, for sine, opposite over hypotenuse. So let's take a look at the first problem. You're going to notice right here it's sine x. So x is the angle that I'm looking at. And when I look at this triangle, you're going to notice side 13. That is still my hypotenuse because it's the longest side and it's opposite that right angle. The side that's adjacent is the 5, and the side that's opposite is that 12. And again, I'm looking at angle x because it says sine x. So if I set this up and I do my opposite, it would be 12, and my hypotenuse would be 13, and I am done with x. Now, the next problem asks me to use sine y, and so that is going to look a little bit different because I'm looking at a different angle. So I'm going to erase these right here. Notice my hypotenuse is still the same, but now rather than 5 being adjacent, 5 is actually going to be my opposite. And adjacent is going to be my 12. So it kind of depends on what angle I'm looking at. So for this ratio then, my opposite is 5 and my hypotenuse is 13. So you can tell between the x and the y, the bottom, the denominator stays the same, but the numbers in the numerator, they change depending upon what I'm looking at. Sine, if I move forward, is not opposite over adjacent for that we had for tangent. It is not opposite over hypotenuse, which we had for sine, but actually it is the adjacent over the hypotenuse. Okay, so if I'm taking a look at this triangle, I'm looking at cosine r. So I'm going to grab the r, which is here. You're going to notice my hypotenuse, again, is that 13. My adjacent would be my 5. And my opposite would be my 12. So if I'm looking at cosine, again, it's the adjacent. So I'm looking at angle r. I would pick 5. My hypotenuse would be 13. If I look at t, that is a different angle here. So of course, I'm going to erase my r, my adjacent, and my opposite, and they now change. So this becomes adjacent, and this becomes the opposite. Notice my hypotenuse itself does not change. And so if I'm looking at cosine t, my adjacent would be 12, and my hypotenuse would be 13. Again, the denominator stays the same because it's the hypotenuse, but the numerator changes depending upon what angle I'm choosing. All right, let's move on. And you can think, boy, this stuff gets so confusing. Like, what do I use? Sine, cosine, tangent. How do I remember it's opposite over hypotenuse or opposite over adjacent? Like, how do I remember that? Well, there's a simple saying. It's called so ka toa, right? The S stands for the sine. The O is the opposite over the hypotenuse. The ka, this is cosine. The A is for adjacent, and that is over the hypotenuse. The T from yesterday stands for tangent. The O is opposite over adjacent. So if you take a look at it and put it all together, so ka toa, so is sine, ka is cosine, toa is tangent, and it tells you which combination I use. Now let's take a look and apply this, because we use trig a lot. If you're in engineering, if you're in carpentry, looking at angles and side measures of triangles. We're going to try to figure out how high the kite is flying. So you're going to notice I got a kite here, and I want to know how high is that flying. And we know that the rope is 75 feet long, and I need to find my x. Well, let's take a look at this. If I know that I have a 40-degree angle here, and how we need to take a look at is how is that 75 in relation to that 45-degree angle? Well, this is the hypotenuse of the triangle. And how is the x in relation to the 40-degree angle? Well, that is the opposite. So if I'm taking a look at these, I've got sine, cosine, tangent. Which one of these three works with the opposite and the hypotenuse? That's right, sine. Sine works with the opposite and the hypotenuse. So to solve this, I would go sine. I'm going to grab the 40 degrees. I'm going to put the opposite over the hypotenuse. And then we solve this like we did before. I want to get the x by itself. I got to get rid of 75. I'm going to multiply both sides by 75. So 75 sine 40 equals x. X equals, and now you're going to grab your calculator. When you do, make sure it's in degrees, like we've talked about. I'm going to go 75 sine 40 equals, and I end up with 48.21, and it would be feet. So rather than having a huge ladder going up to the top of our kite, we can use trigonometry or trig to find out how high the kite is off the ground. All right, let's keep going. And let's do some more practice on this. I need to find the missing side. So let's take a look. I got 30-degree angle, and I need to take a look at those sides. The x in relationship to the 31 is the hypotenuse. The 12 is opposite. So if I think about my trig, so ka toa, which one of these works with the opposite and the hypotenuse? That's right, this one does, sine. And so I'm going to grab sine 31 equals, I'm going to do the opposite over the hypotenuse. So my opposite is 12 over x. I want to get the x by itself, but it's in the denominator. So I'm going to multiply both sides by x. So x sine 31 equals 12. I want to get the x by itself, so I'm going to divide both sides by sine 31. X equals 23.3. And that's my side length. All right, let's move on to the next triangle. Okay, with this triangle, I've got 53 degrees. I need to take a look at my relationships. Well, I know that 56, that is my hypotenuse. And I know my x is right next to that 53, so that's adjacent. So if I go back up to my trig identities, I have to take a look at which one has adjacent and which one has a hypotenuse. You're right, this one, cosine. So I'm going to take the cosine of 53 equals the adjacent over the hypotenuse. I want to get x by itself, so I'm going to multiply both sides by 56. So 56 cosine 53 equals x. And I'm going to go ahead and take my calculator, go 56 cosine 53 equals x ends up being 33.7. And again, that's side length. All right, let's keep going. We're going to go to the next triangle. Again, I need to take a look at the relationships. I got 70 degrees. My x is my hypotenuse. My 6 is next to it, so it's adjacent. So if I take a look at my trig identities, I've got sine, cosine, and tangent. Which one works with the hypotenuse and the adjacent? That would be cosine again. So we're going to go ahead, we're going to grab our cosine. So cosine 70 equals adjacent over hypotenuse. I want x by itself, so I'm going to multiply both sides by x. Divide by cosine 70. I'm going to go ahead and enter that in my calculator. And I end up with 17.5. All right, let's look at this last one in our examples. Again, I'm going to look at my 20 degrees because that's why they gave it to me. All right, and I'm going to take a look at how are my sides in relation. Again, this is the hypotenuse. This is the opposite. It's not next to the 20 degrees. So if I take a look again at my trig identities, opposite and hypotenuse, that would be sine. So I'm going to go back over here and I'm pick up sine. It's sine of 20 degrees. I'm going to put my opposite over my hypotenuse. I'm going to multiply both sides by 6. And I'm going to go ahead and plug this in my calculator. And I end up with 2.05. Again, all you need to do is take a look at the relations, and then you can go ahead and decide which one to pick up. Okay, let's keep going. This is to set up the equation in order to find x by using sine, cosine, or tangent. So let's take a look at this again. Good practice. Again, I got 35 degrees. This would be considered my hypotenuse. This would be considered my adjacent. Okay, look at my trig identities. Again, sine is so, then ka, then toa. And I would put that at the top of a quiz or a test to help you out. So hypotenuse and adjacent would be cosine. So I'm going to grab the cosine 35 equals my adjacent over hypotenuse. Multiply by 4. 4 cosine 35 equals x. X equals, so you can go ahead and plug it through your calculator, and that would be 3.3. Now, just kind of a heads up, some students ask me, do I round to the nearest tenth, or do I round to the nearest hundredth? Those will be in the directions. For this group, we'll just round to the nearest tenth, but if in doubt, just let me know and ask me. All right, let's go ahead to this next one. Again, I'm looking at the 20 degrees. This is adjacent. This is my hypotenuse. So if I look at adjacent and I look at hypotenuse, it's cosine again. So cosine 20 is 6 over x. I want to get x by itself, so I multiply both sides by x. X still by itself, so we're going to divide by cosine. So x ends up giving me 6.4. All right, let's keep going. The more you do these, the better you get. So that's why there's quite a few of them. You need the practice. Again, I'm going to take a look at that 41 degrees. This is my hypotenuse. This is adjacent. So if I look at my adjacent, my hypotenuse, I'm going to look at cosine again. So cosine of 41 equals x over 8. I multiply both sides by 8. Go ahead and plug that in the calculator. 6.0 if I actually round to the nearest tenth. Let's keep going. I'm looking at 71 degrees. This is my hypotenuse. This is the opposite. So I'm going to look at sine. A little bit different. So the sine of 71 equals 23 over x. Again, that's not sin. It's actually pronounced sine. So make sure that you say sine, not sin. We're going to multiply both sides by x. Divide by sine 71. Go ahead and grab your calculators. $24.3. Couple more here. Let's take a look at this one. 27 degrees. This is the hypotenuse. This is the adjacent. So if I'm looking at adjacent hypotenuse, I'm looking at cosine. Multiply both sides by 14. X equals 12.5. All right, two more. By the time we get done with this, you guys will be pros. You'll be great. Okay, I'm going to grab 75. This is my hypotenuse, and this is adjacent. Now, when some of these triangles get really skinny, it can be really difficult to tell what is what. Actually, I'm sorry, that's not adjacent. That's what I said. It's kind of hard to tell. This is actually the opposite of that 75-degree angle because this would be the adjacent. So I'm dealing with opposite and the hypotenuse. Okay, so if I do that, I'm going to grab sine. So the sine is 75 equals, my opposite is x, and then it's over 2. Multiply both sides by 2. So 2 sine 75 equals x. X is 1.9. And then finally, the last one, yay! Okay, we've got 40 degrees. Notice that I have the opposite and I have the adjacent. And so this is going to be tangent. Tangent of 40 degrees equals toa, oa, opposite over adjacent. Multiply both sides by 56. So go ahead and plug that through. X is 40 7.0 if you're rounding the nearest tenth. Okay, so that is it. That is sine, cosine, and tangent in a nutshell. If you have questions, please make sure that you let me know.